Today, we are going to decode the colorful language of one of the most essential components in all of electronics, the mighty resistor. So let's get right into it.
Electro knowledge. Power up your concepts.
You know, it's a question pretty much everyone in electronics has asked at some point. You see these little components everywhere, covered in these colored stripes. So, what's the deal?
Well, believe it or not, those colors are far from random. They are actually a secret code, a really clever system that tells you everything you need to know about that resistor's value.
So you might be thinking, why not just print the numbers on them? And that's a fair question. The simple answer is, well, their size. Most resistors are just way too small to print legible numbers on. This color coding system is just a brilliant, universal solution to that problem.
Okay, let's start with the most common type you're going to see out there, the 4-band resistor. If you can understand this one, you're well on your way to understanding all the others.
Reading a 4-band resistor is actually a pretty simple process once you know the steps. The first band, that's your first digit. The second band, you guessed it, is the second digit. The third band is what we call the multiplier. It basically tells us how many zeros to add to our number. And finally, that fourth band, that's the tolerance, which is all about the margin of error. We're going to circle back to that one in just a bit.
And here it is, the decoder ring. This chart is the key to everything. It shows you exactly which number each color stands for, starting with black at 0 and going all the way up to white for 9. You can pretty much think of this as the alphabet for our resistor code.
Now, trying to memorize that order can be a little tough, so people have come up with some clever mnemonics to help. A really popular one is, big brown rabbits often yield great big vocal groans when gingerly snapped. You see how the first letter of each word corresponds to a color? Black, brown, red, orange. Pretty neat, huh?
All right, let's put this into practice. Imagine we have a resistor, and its first 3 bands are brown, black, and orange. We look at our chart. Brown is 1, black is 0. So that gives us the number 10. The third band, orange, corresponds to the number 3. So our multiplier is 10 to the power of 3, which is 1,000. So we take our 10 and we multiply it by 1,000. That gives us 10,000 ohms, or as you'll often see it written, 10 kiloohms. See? Not so bad.
So, now that you've got the 4-band system down, let's level up and look at 5-band resistors. These are what you'll find when you need a much higher level of precision.
The key difference is actually super simple. A 4-band resistor has 2 bands for its digits, right? Well, a 5-band resistor has 3. This lets you get way more specific with the value. After those first 3 digit bands, the 4th band is the multiplier and the 5th one is the tolerance, just like before.
It's that extra third digit that makes all the difference. It allows for much finer control over the resistance value. You'll find these precision resistors in really sensitive stuff, like medical equipment or scientific instruments, places where getting the value exactly right is absolutely critical.
Okay, let's talk about that last band again, the tolerance band. What is it really telling us?
So here's the thing. No manufacturing process is perfect. The tolerance band tells you the acceptable margin of error for that resistor. It's the manufacturer's guarantee that the actual resistance value is within a certain percentage of what the color code says it is. This is super important because in a sensitive circuit, a resistor that's too far off its stated value could throw everything off.
The most common colors you're going to see for tolerance are gold, which means plus or minus 5%, and silver, which means plus or minus 10%. And hey, if you ever see a resistor with no tolerance band at all, it's usually assumed to have a pretty wide tolerance of about plus or minus 20%.
But what about all the tiny components inside your phone or your laptop? They don't have colored stripes on them. That's because modern electronics have moved to something called surface mount devices, and they use a completely different marking system.
Yep, these are called surface mount devices, or SMDs for short. And they are so incredibly tiny that even color bands are too big. So instead, they use a compact little numeric code that's printed right on them.
The system actually works just like the color bands did. For a 3-digit code, the first 2 numbers are your significant digits, and that third number is your multiplier. It tells you how many zeros to tack on the end. So a resistor marked 751 means our digits are 75, and the 1 means we add 1 zero. So that gives us 750 ohms. Simple as that.
And just like that, you've cracked the codes. Seriously, you've got this. Let's just do a quick recap of everything we've gone over.
We've looked at the standard 4-band system, which you'll see all the time. We talked about the more precise 5-band system for those high-accuracy applications.
And finally, we covered the numeric codes you'll find on modern SMD resistors. They're all just different languages for saying the same thing.
The main takeaway here is that what looks like a complex, secret code is actually a really simple and logical system. With just a little bit of practice, it's a language anybody can learn. And once you understand the system, reading a resistor truly becomes as easy as reading numbers.